transforming musical linguistic objects, help machines.
Greetings from Cyberdelic Space. This is Lorenzo, and I'm your host here in the Psychedelic Salon. And while I'm a bit tardy in getting out today's podcast, several of our fellow saloners didn't wait for me and instead sent in a donation to help with the expenses of producing these podcasts and to ensure that the plans for Psychedelic Salon 2.0 continue apace. And these great souls are John P., Daniel R., John W., and longtime saloner and donor Juan P. Now, normally right now I'd explain that the latest little heat wave in Southern California made it impossible for my old computer to chug along in the heat, thus making this podcast a few days late. But I'm not going to do that, even though I think I just did that. But I'm not going to do that because of a wonderful note that I received in the mail from a longtime saloner and major contributor to the salon, Margene M. And here's how she began her letter. Dear Lorenzo, I'm happy for you making this decision to pass it on. For several years now, I have rolled my eyes as you would begin another podcast making apologies for how tardy it was. I'd be thinking, come on, Lorenzo, give yourself a break. And so, Margene, I'm giving myself a break, and hopefully you won't get too much eye-rolling exercise today. And by the way, thanks for reminding me to relax a bit. I've essentially fallen so far behind on my email lately that I've missed a chance to make another appearance on the Third Eye Drops podcast, and my promised breakfast with fellow saloner Darren B. has fallen through temporarily, not to mention a whole bunch of responses still due to donors and fellow saloners who have used our comments forum to send me a message. So I'll eventually catch up, I'm sure. Okay, so I'm still beating myself up a bit, Margene. I'll try to relax even a bit more. At least for today, when my focus is to finally get this podcast out. And so speaking of today's podcast, as you know, if you've been here in the salon for a while, I haven't been playing the Saturday night sessions of Terence McKenna's workshops where he explains his ideas about the time wave. Now, if you've let my grumpy thinking infect your mind as to the time wave being a dead end, here's a suggestion. When you listen to Terence talk about the flow of earthly history in regards to the time wave, instead of thinking about time and all of human history, think instead only about the flow of time in your own life. What if his ideas about a time wave actually do have some bearing on our own life trajectories? I'm not sure that this will be of much use here, but his ideas do seem to resonate better with me when I think on a smaller scale. And I'll have more to say about that after we first listen to a complete explanation about his time wave hypothesis. Now, about an hour and 20 minutes from now, you're going to hear Terence talk about a time over a year earlier when the so-called Watkins objection to his time wave hypothesis was first raised. And if you've been with us here in the salon for a while, then you may remember back to my podcast number 472, where we heard Terence talking about having just returned from meeting with Watkins in Palenque, and that he would be returning to his home in Hawaii to think about it. Well, now we get to hear what his thinking about the Watkins objection led him to.
Okay, well, tonight has become sort of a set piece in these things, because we always seem to set aside Saturday night for a discussion of the time wave. Some of you who have been to 5, 6, 7, and 10 of these things can deliver this lecture verbatim. However, even for you, there are tiny thrills this evening, because there are some new things to say about the time wave, believe it or not, things never before said in public, if I get to them. But that all lies in the realm of the details. So before the details comes the general introduction to the game. And the idea here, it's an indulgence of me that you sit and listen to this. All these other talks I give, are essentially passing on information to you about drugs or technology or philosophy or something like that. This is my own thing, so entirely my own thing that no one has ever even tried to steal it from me. So if it's right, it's all my fault, and if it's wrong, it's all my fault. Although that, too, may change, may be about to change. The notion, simply put, is what we have here is a mathematical model of an idea about how the world works. And you can accept the idea without accepting the mathematical model. What the mathematical model does is gives hellish precision to something which otherwise would be a kind of loose-headed after-dinner speculation, a kind of how would it be if thought. And this idea came to me as these overarching general metaphors seem to do if you study the history of ideas, sort of all in a flash. Get comfortable here.
You gonna keep going?
No, this is I go down to the peyote button. Okay. So, and I used the vocabulary of Alfred North Whitehead's metaphysic to surround these mathematical ideas. So here is the basic notion. The idea is that time, which in Western physics and philosophy is assumed to be flat, or what Newton called pure duration. And the only adjustment of that idea that's ever taken place in the scientific canon is that Einstein added the very slight caveat that in the presence of massive magnetic fields, the space-time continuum became very, very gently curved. So throughout the evolution of the Western notion of time, two notions have been in play, that time was either perfectly flat or that it was damn near perfectly flat and that it had a very smooth distortion from perfect flatness. The roots of this assumption, which is all that it is, lie in Greek mathematics, because in Aristotelian physics it was thought that the orbits of the planet were perfect circles, and that the perfect, that is, bilaterally symmetric geometric shapes were somehow the key to understanding the physics of the cosmos. As empirical investigation of the nature of nature proceeded, one by one, these perfect Greek models had to be tossed out, simply because the evidence supported other conclusions. In other words, careful examination of the movement of the planets reveals that they do not move in perfect circles. They move in ellipses. The entire system of Ptolemaic astronomy was a system of nesting planetary orbits in perfect circles with smaller circles, with smaller circles, with smaller circles, in order to avoid the great simplifying conclusion that it wasn't circles at all, it was ellipses. And one by one, as I say, these ideas have had to be given way. The one that we've held on to the longest is this idea that time is a perfectly smooth surface. And to illustrate what that means to science, you have only to think of the first thing you're told if you study statistics, which is chance has no memory. If you study statistics, they will give you a problem like this. A man has flipped a coin 49 times. It has come up heads. He's flipping the coin the 50th time. What are the odds it will come up heads? and the odds, according to the science of probability, are 50-50. Flying under the battle flag of chance has no memory. So in other words, in statistics, you're taught that the fact that you've had heads 49 times doesn't prejudice you toward heads the 50th time. No gambler would take this seriously for a moment. Gamblers aren't statisticians. Gamblers believe in runs, and essentially they believe, as I believe, that some places in time favor heads and some places in time favor tails. And if you can sense by any means where these times are, you can probably make a fortune. Now, the reason this idea of the flat duration of the temporal continuum has been so tenaciously hung on to in Western science is because if you carefully deconstruct Western science, it can't do business without this notion. Because the central idea of the Western scientific method is something called the experiment. The experiment is a special situation that you set up that is somehow designed to reveal or trap or cast into high relief an aspect of nature normally occluded or buried in other processes. The experiment is a way of making naked the particular phenomenon that you're trying to look at. But notice that the concept of experiment contains built into it the idea of replicability, meaning that the experiment is not something done once. The experiment is something which must be potentially doable an infinite number of times, or tens of thousands of times. And experimentalists have the phrase and the notion, what they call the restoration of initial conditions. In order to repeat an experiment, you must be able to restore the initial conditions. Let's say you want to know if the light bulb is working. We will perform an experiment. We will turn on the light. We throw the switch, the light comes on. Yes, the light is working. Now we turn the light off. We have just restored initial conditions to the pre-experimental situation. For the idea of experiment to mean anything, you must be able to restore the initial conditions. Well, now suppose that every moment in time has a unique character, that there is something special and unique about every moment in the serial time continuum. If that were found to be true, then initial conditions can never be restored. It's a fiction. It's an illusion, a hallucination of the empirical mind. Now, science, when it does its experiments, it would never say this experiment will give the following data on the charge of the electron, but it must be performed on Tuesdays before noon. That would seem to a scientist an absurd statement, because scientific statements are what is called time invariant. They work on Tuesdays, Wednesdays, before noon, afternoon, anytime, because the assumption is made that they are time invariant. The idea that I wanted to explore, because it seemed to me, based on my own personal experience as a living person, and also it seemed to me based on my psychedelic experience, that in fact every moment is unique, and that we can never go home again, and that where you are situated in the space-time continuum is absolutely an irreversible determinant of your destiny. So temporal invariance is a fiction. And you could almost redefine science from this point of view, science as we have known it up to this moment, as the following. Science is the study of those phenomena so coarse-grained that their situation in the space-time continuum does not affect their outcome. These are very coarse-grained phenomena indeed. Things like ball bearings rolling down inclined planes, electron charge transfers, very basic mechanical things seem to be time invariant. But now, when you look at less coarse-grained things, like the lives of animals, the destinies of nations, love affairs, corporate takeovers, wars, revolutions, art movements, these things are incredibly time-dependent. They are, in fact, almost entirely creatures of time. An affair conducted in France in the 30s one way won't fly in America in the 80s done the same way, and it would be preposterous. We don't expect our love affairs to be exact repeats of previous love affairs, or our meetings with our attorneys to be exactly like previous meetings with our attorneys. These kinds of higher grade phenomena are distinguished by the fact that they're unique and they're...
Chaos theory in space?
I don't think so. I think that's saying something else. My first concern was to point out the limitation of the scientific method because it's based on probability theory, and then to say we need a better theory. If what I'm telling you is so, then a science that bases itself on probability theory will never be able to bring nature into true focus. It will be able to get a picture of these coarse-grained phenomena, but it means there can be no science of society, no science of psychology, no science of the large-scale behavior of complex systems of any kind, because probability theory levels out the differences. So my notion was that rather than the flat surface of pure Newtonian duration, we should play with the idea that time has a local structure and a local fine structure. In other words, that far from moving over a perfectly smooth surface, as we move through time, we are experiencing an ebb and flow of probability. If we could somehow dipstick this ebb and flow, we would have a dial, we would have a meter which said heads here, tails here, and as you watched it, you would see it go toward heads, then toward tails. This is what it's favoring. Now it's favoring heads. Now it's favoring tails. Now heads. Now tails. In other words, probability is not a constant phenomenon. It's a fluctuating phenomenon. Somewhat facetiously, I suggest to you that if time were truly invariant, and if the odds of a coin flip are truly 50-50, then the coin should land on its edge every single time. That's the rarest of all outcomes in a coin flip. You have to spend years in sleazy bars with sticky tabletops in order to see a quarter land on its edge and stand there. And so when you put this to the statisticians, then they say, well, then there are minor factors impinging, and then with some kind of magic sleight of hand, they explain how the universe decided whether it would be heads or tails. Well, if in fact time is a fluctuating variable, it can be portrayed as any fluctuating variable is portrayed against some kind of a power axis against time on the horizontal axis. And if you knew then how to scale this fluctuating curve against the time you were living in, you would begin to get a map of the ebb and flow of probability. So that's part of the idea I'm trying to put forth here. Now, to bring this around, I've tried to talk about two phenomena that I, as a simple, ordinary person, have observed about nature, that I suspect you too have observed about nature, but that science, for some reason, has chosen to completely ignore, and when pressed, deny that the phenomena I'm about to discuss exist. And yet, to me, they are self-evident. They have a relationship to each other. The first phenomenon I've noticed that science makes nothing of or denies is that the further back in time you go, the simpler things become. Or, to stand the statement on its head, beginning at the earliest moments of the universe has grown ever more complex. And this is a true statement whether we're talking about physical systems, because the universe begins as a physical system of pure electrons. Quickly, simple atomic systems are formed, hydrogen and helium. They aggregate under the force of gravity. Notice how things are becoming more complicated. At the center of these gravitational aggregates, pressure and temperature rises. Suddenly a new phenomenon bursts into being, fusion. It cooks out heavier elements like sulfur, iron, and carbon. And where a cosmic moment ago we had a very simple universe full of only unpaired electrons, suddenly we have a universe full of all kinds of atomic species distributed at various volumetric densities and so forth and so on. And then with the advent of carbon, you get long-chain polymers, you get molecular chemistry. Before you only had atomic chemistry. Some of these long-chain polymers begin to transcript themselves. Now you've got some kind of self-replicating molecular system preserving information. It quickly becomes non-nucleated life, which quickly becomes nucleated life, which then becomes multicellular life, which then becomes complex life. Sex is invented, the phyla form. You see what's happening? As we're approaching the present in this description, the universe is filling up with complex phenomena of many orders of magnitude, stars, galaxies, cells, organisms, ecosystems, yada, 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 on and on. And then very recently in this picture of crystallizing or condensing complexification, you get higher animals using language, inventing culture, building tools, transmitting messages through wires, enclosing the entire planet in a communication system, on and on and on. So, point one about this that science has missed is the universe apparently, or it is a reasonable statement to say, the universe has an appetite for complexity. As the universe grows, it grows ever more complex. Now, if you set it back in some domain, here's a planet covered with jungles and oceans. Its home star undergoes a hiccup. Jungles and oceans are reduced to vapor. The atmosphere is blown off. This is a great simplification. What happens? the system immediately sets itself going toward restoring and surpassing the originally achieved complexity. So it isn't an inevitable and everywhere march toward complexity. It's a march towards complexity that can be deflected by large-scale catastrophe or statistical fluctuations, but it always picks itself up out of the ditch and begins again the forward march toward greater complexity. And notice that this is occurring across domains. This is not a phenomenon of biology or sociology or physics. It's a phenomenon of all three and more. It's a phenomenon that seems to permeate all levels of organization. That's point one. Point two is, looking at this same data that I just laid out for you, notice that the closer we get to the present, the faster this complexification is occurring. So that, the cool down from the molecular from the electron plasma into the aggregate of early stars, this took a long, long time. And then the cooking out of heavy elements took a long time, not as long as the first step, but hundreds of millions, perhaps billions of years. When you enter the realm of planetary biology, suddenly change through the advent of genetic transfer and reshuffling of genes is vastly accelerated. And where before change took hundreds of millions of years, now it's being accomplished in millions of years. Well then, when culture and language using creatures like ourselves come onto the scene, it's like a hyper acceleration of that already accelerated process. And now change is coming not in millions of years, but every few hundred years or every few decades. And the entire experience of human history has been one of ever accelerating change and novelty, to the point where now in a single lifetime we experience more change than people 50 years ago experienced in the previous 1,000 years. I mean, when you think about the fact, this is 1997. 100 years ago, there were a few telephones. There were 0 automobiles 100 years ago. There were 0 aircraft 100 years ago. There were no computers of any sort. There were no antibiotics. TV was undreamed of. I mean, you know all of this, but we stand around saying things never change. When in fact, we are involved in the most accelerated, asymptotic ascent into change, so far as we can tell, the cosmos has ever known. Well, so these are the two phenomena that I took note of, and then I couldn't, being, in Barry's sense, as we discussed it, being a rationalist, I saw no reason then, looking at this process, which has been running since the Big Bang till right now, to see any possible argument, force, or situation that could cause the universe to suddenly change its mind about that being the direction it wants to go in. No, the universe wants to go toward greater novelty, and it wants to go there faster and faster. And it's possible, since this novelty acceleration is so asymptotic, that most of the creative unfolding of the universe will actually occur in the last few days, hours, or minutes of its existence. This is the basis of my much misrepresented and misunderstood enthusiasm for what some people dial in as the end of the world, or the apocalypse, or the eschaton. Because it seems to me, if you try to clock these accelerating rates of change, honest examination of the situation leads to the conclusion that it is now moving so fast that within our lifetimes it will approach speeds that from a human perspective appear infinite. In other words, more change is going to take place in the next 10 years than has taken place in the previous 5 billion years. And, we're going to be present for this. This is an idea almost the exact opposite of ordinary causality. The idea of ordinary causality is that there was an enormous cosmic explosion at the beginning of things, and that from that moment everything has been spreading out, cooling down, and organizing or disorganizing itself as it may, but that there is no goal, purpose, telos, vector, arrival point, or any other formulation you might make that indicates that the universe knows where it's going. I simply don't believe this. It appears to me that the universe does know where it's going. It's going into deeper novelty. I call the universe a novelty-conserving engine. What that means is when it produces novelty, it tenaciously hangs on to it. It does not lightly give up a species, a molecular arrangement, a star system. These things are held together. They're what Eric Jonsch called metastable, or what Rupert Sheldrake calls their morphogenetic field. Their appetite for coherency perpetuates them through time. Okay, well, so that's the introduction to this idea, and I don't think anything I've said to this point, though it is in fact scientifically radical, it's not very arguable. I mean, the facts are on the table. You can like it or not like it, but this all seems to be the case. The universe is under is being shaped by an attractor of some sort that finds self-reflection in complexity. So you could almost say we are being pulled forward into the future by something that is shaping us in its own image as it draws us ever nearer to its aura, to the umbra of its presence. Okay. Mm-hmm. Closed systems tend to run down into entropy. It is only a cheerful assumption that the universe is a closed system, and is certainly not true that biology is a closed system. When an astrophysicist tells you that the universe is going to end in heat, death, and entropy, do you know what value he is giving biology in his model? 0. Precisely dot. Is that reasonable? They say, well, biology, we only have located it on one planet. It's so ephemeral. It does seem to be a slight counterflow to the second law of thermodynamics, but it would be preposterous to suggest, etc., etc., etc. Not at all, for the following reasons. The average life of a star is 500 million years. Now, we happen to be in orbit around an extraordinary stable type of star. This star is older than that, perhaps 8, 9, 10, like that. But the average life of a star is 500 million years. We know that life has existed on this planet for 1.83 billion years. So nearly 4 times longer than the life of the average star in this universe. So to suggest that biology is not tenacious, to suggest that it's ephemeral and not in for the count, is just to simply ignore the data. In the one sample we know of, biology has proven itself to be 4 times as enduring as the stars themselves. So I think it is unnecessary to worry about the second law of thermodynamics. It will be reversed if life can break out to a sufficient level of, and may already have been reversed. After all, we don't know what the distribution and extent of life is in the universe. Okay, so all of this is like, it's a nice idea. It's, yeah?
I'm not very knowledgeable about this, it's all new to me, but at what point does, if novelty is happening faster, like the events of novelty are closer together, well, at what point is it not novelty because it's not new anymore?
That's the point where all novelty that is possible has become manifest. In other words, when the amount of novelty in the universe reaches infinity, the program of expressing novelty will be finished. All possibilities will have been realized. Well, okay, so this is a wrap. It's pretty good. It sounds okay. It deals with certain data. It opens certain vistas. But it's just a wrap. To go to the next level in the game of theory making, you have to bring in mathematics, and you have to make precise predictions about the system you're studying. And then if these predictions are judged to be true, and that's a very tricky term, and if you're interested in it, you should read somebody like Imre Lakatos, who wrote Criticism and the Growth of Knowledge. The question, what is true, what is proof, what is falsified evidence, so forth. These are questions that the philosophy of science deals with in detail, and we can't here. But anyway, if your theory is judged to be true, that's the level at which paradigm shifts occur ever since the Greeks, at the mathematical level. So since 1971, under the inspiration of my trip to the Amazon and mushrooms and so forth, have been trying to develop a higher dimensional model of the space-time continuum that would allow the extension of the precision techniques of physics and to some degree biology into domains like art history, culture, and even our own lives. And so I've developed something which I call novelty theory. And I use the vocabulary of Alfred North Whitehead because it's a pre-existing vocabulary created by a very, very, very reputable mathematician, which, as this story will make clear, I am not. And so novelty theory. But novelty theory needs an equation to go up to the great simulacra of true science with Newton and Einstein and Huygens and Maxwell and those people. And so over the past 20 years, I've tried to do this, and I've produced a mathematical equation, which is a fractal algorithm, which is a self-similar recursive curve that I modestly propose we substitute for the zero in Newtonian physics that describes the curvature of space-time. And I won't say too much about how I derived this, except to say that it was by a mathematical deconstruction of the I Ching. The I Ching is, as you probably know, a Chinese oracle of great antiquity, and one of the things that has struck various people who've become involved with it, Leibniz, Benjamin Franklin, Carl Jung, that it seems to work. Like psychedelics, it seems to be an exception to the general rule that this woo-woo stuff never works. the I Ching works and why it works has been a great deal of ink has been spilled upon this subject. Jung's explanation of synchronicity, if you carefully deconstruct it, is no explanation at all. It basically says it works because it does work. I wanted to go a little deeper than that. I think that what I want to say about this evening is just to give you a metaphor. Because if someone were to attack me, and I've been attacked on many levels, the attack that I used to feel most stinging was one that sort of proceeded along these lines. So you want to make a revolution in physics based on a Chinese oracle? Is that what you're saying? You propose a redefinition of the Newtonian space-time continuum based on a 3,000-year-old occult fortune-telling method. Is that right? I understand that kind of attack. That's how I attack. That's a withering attack. And so then I had to think, why do I want to do that? That sounds awfully squirrely when put that way. So here is my defense of it now. The claim of the I Ching, it is called the Book of Changes, is that it describes change. So now let's make a metaphor here, which I think will help us understand what must be going on. And this is the only point in any of my teaching where there is any chance for what is called a visualization or a experiential thing. So make the best of it. Close your eyes, damn it, and think of dunes, sand dunes. Get a good, clear picture of some sand dunes in your head. Okay, now, the thing to notice about these dunes that you're looking at is that they look like wind. Dunes look like wind. Now, what does this mean? Well, dunes are made by wind, and somehow they reflect the thing which made them. Let's think of each grain of sand as a bit in a computer. Let's think of wind as a program which is being run on that computer. The program is run, the bits rearrange themselves furiously, and when the program stops running, what we have is a lower dimensional slice of this pressure gradient phenomenon in time, the wind. The dune is, in some sense, the signature of the wind. If you knew how to backward engineer from the dune, you could create wind. Do you see what I'm getting at here? All right, now, forget sand dunes, forget bits in computers, think of genes. You are made of genes. All life on this planet has always been made of genes. And think of time as wind. This wind has blown for 1.84 billion years. And the bits, the genes, have been rearranged into what? A lower dimensional slice of the structure of the force that created them. And what was the force that created them? Time. Time created them. And so, in their structure is the architecture of time itself. You can backward engineer out of the genetic material toward the architectonics of the physics of the temporal domain. Okay, now, let's go back to Zhou, China, 3,000 years ago, a culture as obsessed with time as we are with matter, a culture that didn't build super colliding whatchamacallits, but instead perfected meditation techniques, stilling of the heart techniques, yogas, that were designed to suppress physiological functioning until it fell very close to death itself. And then the inquiring minds of generation of sages observed within the core of organism flux of some sort, the coming and going of variables. That's all we have to say, the coming and going of variables. And, like good scientists everywhere, they created a special notation language. And out of this effort to note, catalog, and understand the temporal variables, soon realized to be not infinite, but in fact finite, quite finite, in the same way that all the physical universe can be built up out of 108 or 106 physical elements, the entire temporal domain can be built up out of 64 elements. And this 2 to the 6th number, 64, it's built into the I Ching, it's built into the structure of the DNA, it's built into the algorithm that I've developed for tracking time. So my answer to the person who sneered at me using the I Ching as the basis for this is the I Ching is only an artifact that indicates a database of knowledge about temporal variables that has been coded into a very ethnocentric notation system, the 64 hexagrams with their commentaries. But by mathematically tearing that apart and treating it formally, we can tease out of all that data this pattern, this fractal, and we can deal with it with our own technologies and our own epistemologies. And we can replace the zero quality of space-time with a much richer description. Now what we have is a Cartesian line, a flowing graph that depicts the ebb and flow of novelty in time, if we can correctly calibrate it to our own historical domain. So now I want to show you this wave and talk.
This guy asked this question. Did you sort of unleash this response right back to him at that moment? Did you spontaneously, or did you later in your hotel room go, shit, I should have?
No, I think I'm the guy, and then I thought up the question and I thought up the answer. It was probably something like that.
So basically, you're saying that the I Ching, one side of this is the I Ching is a artifact of a metaphor for evolution.
Precisely. Yes, I think, you see, the I Ching, it was old by the time the Han Dynasty got it. The earliest commentaries on the I Ching are early Han Dynasty, about 300 BC. It was ancient by that time. No one knew what it was.
Well, what means was it constructed?
No one knows. I mean, it was called the Book of the Zhou in the early period of Chinese history. It's not even thought to be Chinese. They don't claim it. They say it came from somewhere else. And the story of King Wen, this person who got put in jail for political rabble-rousing and then formulated it, there's no historical basis for that. I mean, that's a founding thing. It is interesting, though, that he was put in jail and then he discovered it. In other words, he had to keep still for a long time somewhere, and then he found it. I don't think that the Confucians of the Han Dynasty had any better grip on the I Ching than we do. It was up for grabs, and then it became a simple country oracle for centuries. What I did with the I Ching is remember I confessed earlier I'm no good at languages, so I just dumped the whole Chinese thing. I said, I don't need to know Chinese, it's pre-Chinese. And I said, it's pre all these commentaries, so the only thing you can deal with, if you really want to deal with the I Ching itself, is the 64 hexagrams in the King Wen sequence. That's the traditional sequence. And that's what I dealt with and studied it for mathematical order to try and figure out whether it was simply 64 hexagrams in a traditional but jumbled order, or what were the principles of order that underlie it. Well, I won't go into that very much this evening, but for those of you who are keen for the I Ching and can take a look at it when you get home, if you look at the King Wen sequence, the very first thing you notice if you're paying attention is it isn't 64 hexagrams, it's 32 pairs of hexagrams, because in each pair, the first turned upside down gives the second. So if you look at it, number 3 is 4. Turn 3 upside down, you get 4. Turn 5 upside down, you get 6. And so on. Now, there are 8 cases where when you turn it upside down, it doesn't change. You meet the first exception in the first 2 hexagrams. The first hexagram is all solid lines. Turn that upside down, and you've still got all solid lines. In these 8 cases, then, a second rule is obviously invoked. It's that if turning a hexagram upside down causes no change, all lines change. And so as you go from hexagram 1, all solid, turning it upside down, no change, therefore all change, therefore number 2, all broken. That's the first pair. Second pair, number 3, turned upside down is 4. 5 upside down, 6. 7 upside down, 8. Then I think 9 to 10 is another one of the ones with the exception, and all lines change, and so forth and so on. And there are many other properties. And I worked on this in isolation for 20 years. Now I'll show you the output and explain the nature of the game, and I do want to leave time to go into the new stuff, because the new stuff is the new stuff. Let me explain what's going on here. What you see on the screen, this is time, and this is a measurement of habit versus novelty. The higher the graph, the more habit in the system. The notion here is that this is a push-pull thing. The opposite of novelty is habit. In every moment, hour, day, year, millennium, kiliocosm of time, habit and novelty are locked in some kind of dynamic struggle. Yeah?
You mentioned this is a Whitehead thing. I've never read Whitehead's book, but did he use it in a opposition or a similar kind of a context that you were using it?
He didn't have this wave. He invented, habit and novelty. Yeah. This is all Whiteheadian metaphysic. And the book to read, if you're interested, the essays are wonderful, but that's not where the meat is. The meat is in process and reality. I mean, the great unread philosophical tome of the 20th century, Process and Reality by Alfred North Whitehead. Tell your friends. Anyway, so this is time, and this is habit going up. So, for instance, when the wave moves sharply downward like this, we call that a plunge into novelty. When the wave moves upward like this, we call that an ascent into habit. And the idea is that if we get it properly scaled against historical time or the evolutionary record or the astrophysical record, whatever kind of phenomena we're looking at, if we get this thing properly scaled against it, it will give us a description that will match our intuition or our databases about these particular phenomena. And here's a payoff. It'll give you a map into the future. In other words, future history is no different from past history. So if I'm right, can give us a picture of future time that we haven't yet lived through. Now I want to, what we've got on the screen time-wise here is 6 billion years. The entire history of the Earth, the entire life of the planet. This huge plunge into novelty here is in good accordance, given the scales of how much we know about these events, with the impact. The Earth collided with a Mars-sized object, and the Moon was created out of the detritus of this catastrophe. I know this sounds like it comes straight from Velikovsky and Sedona, but it's actually, this is what planetologists believe. It was on the cover of Scientific American, October 1994, with the words, "A Mars-sized object collided with the Earth to create the primitive Moon." So this happened right here as part really of the condensation of the planet, the stabilization of its surface, the infall of planetesimal stuff was ending. And life appears, and then there's the crisis of the naked prokaryotes being oxidized by oxygen, which is then a poisonous gas. And then once that was overcome, the rest pretty much proceeded. To give you an idea of how much time is on the screen, from the top of that little pimple there over to where we're sitting tonight is about 650 million years. In other words, virtually the entire career of organic life out of the sea on land is in this part of this thing. Now, what I've done is I've configured it for a zoom mode, and I want to do a zoom movie in on the present, and I will narrate what's going on. Seek minimum. No. Just a moment. No. What happened here? Zoom. Yes. Seek minimum. No. Approach factor. 2. I'm going to enter a value of 2 as an approach factor. What this will do is slice the screen in half, and each screen we see will be twice as much detail and half as much time. So it will be more clear as we actually do it. So there's 6 billion years on the screen, now 3 billion years on the screen. Now 1.5 billion. That's the career of life out of the sea. 750 million years. 375 million years. Those are cometary impacts, glaciations. There's 187 million years. 93 million years. See the catastrophe that wiped out the dinosaurs? 46 million years. 23 million years. The fractal has recurred. You saw that pattern before. 11 million years. 5 million years. Again, now those are ice ages. 2.9 million years, the domain in which we arose. 1.4 million years. 732,000 years. Yes, it's a fractal. Certain patterns will recur. 366,000 years. 183,000 years. 91,000 years, the last 100,000 years. And see, 45,000 years. 22,000 years. I want to stop it now for a minute. Sometimes, depending on who's in the audience and how much time we have, we linger as we go through those things to discuss sunspot cycles, planetesimal impacts, the bust-up of Gondwana land, whatever your thrill is. But of course, people can argue that the dating of these kinds of things, like the Permian explosion, the breakup of Pangaea, are themselves subject to dispute on scales of tens of millions of years. And so you say, well, maybe it's working, maybe it's not, who can say? I should tell you at this point that where the end point is determines where all the other data points fall. This should be self-evident. And so you have to choose an end point. The end point that I've chosen that's generating all this data is December 21st, 2012 AD. In other words, a date less than 20 years in our own future. This has gotten me a lot of flack. There's something about it. People find a prediction of great change more palatable the further off in time you place it. So, but on a scale of 6 billion years, I could be off 60,000 years and have made an error of 0.001%. So people who sneer and say, well, it didn't happen like you said it happened, well, maybe I was 0.00001% off, and that, Yes. Okay, this is the last 22,000 years, and I'll just briefly interpret it for you so that you can...
I don't understand what the point was there.
Didn't I tell you this afternoon that the most uncool thing you can do is ask someone, what did you just say? And I'm a worse case than most because the truth is I haven't the faintest idea what I just said. Would you care to refresh me? I mean, it's a flaw in me. It's not a problem with you. I just can't remember.
It was about being off a little bit.
Oh. See, I'm saying, okay, the end of the world or the condensation of the eschaton or whatever it is will occur at 11:18 a.m. December 21st, 11:18 a.m. Greenwich Mean Time, December 21st, 2012. But if I were off 60,000 years on a scale of 6 billion years, I'd have made an error of 0.001%. That's all. I'm just pointing out that where timescales are so big, precision begins to take on a different meaning.
So if it doesn't happen at 11:18, don't blame you.
No,
you might be really close.
I won't defend it, though. I've decided to get a life after 2012, no matter what happens. I got the curve. I had the curve, and I knew I had to fit it to time, and so I did what good statisticians do. I sought what's called a best fit curve of data to algorithm. In other words, and people say, well, but history is not a quantifiable phenomenon. How can you draw a curve of the novelty of history to fit to your novelty wave? Well, true, it isn't a quantified phenomenon, but you can make certain broad statements about history that if you don't agree with them, you're going to have a real uphill battle ahead of you. Here's such a statement. The Greek golden age of Pericles was truly novel. Here's another one. The Italian Renaissance was truly novel. Here's another one. The 20th century was truly novel. Okay, so now we have 3 data points right there. So we know that if our curve has to have troughs at those 3 points anyway, or it will be wrong, and then we can begin to talk about more arguable points, the birth of Islam, or the fall of Rome, or the dynastic Egypt. These things are more arguable. So you start with the easy cases, you try and get a good fit, and then you look at the harder cases and see if your wave is still fitting, and then you proceed to still finer detail. And I did this for months. At first I thought that, well, I had many ideas, but I finally decided that 2012 was the date. And then, I don't know whether this complicates things or helps, depends on your mentality, but then I discovered that the Mayan calendar ends on the same day.
I was just going to ask that.
To my mind, this was a complication I didn't need. Other people said, well, it proves you're right. I said, no, it muddies the water. It brings in a bunch of squirrels from L.A., and it brings in the this and the that. And I would have just preferred to stand alone. But for better or ill, the Maya and I, using different mathematics and different assumptions, calculated our way out of all eternity to the same day. Now, the only thing I have in common with those people is we both take mushrooms. They did, I do.
They also revered elves.
They also what?
Revered elves.
Revered elves.
It also laid you open for a lot of trashing, a lot of, comparisons to you and Jose Arguelles and stuff like that.
Right, it was not helpful in my estimation. Why they calculated the end of their world to occur centuries after the actual collapse of their world is lost in time. We don't know. I mean, because I was so dependent on the mushroom for the production of this theory, it's almost as though there's a barcode in there and says, wherever in space and time you are, know that, and then it gives it in your own notational system. The following date is important. Good.
Don't you think it would be possible if these elves in the other dimensions were able to impart some knowledge to those that crossed the barrier and entered into their domain, that they could come back with it and they could also find out this time sequence?
Well, what's interesting is that the numbers that go into the formulation of the Mayan calendar aren't very similar to my numbers. So it's like we're triangulating here. It is interesting that Mayan numbers look somewhat like hexagrams. It's possible that ancient knowledge systems are all about... I think what it is there's a message that wants to be told. I don't know who's telling it. Is it the planet? Is it the extraterrestrials? Is it the DNA? But there's a message that wants to be told. And it's not some, fuzzy thing like love one another. It's more in the nature of a mathematical revelation of some sort. You're supposed to be able to figure out love one another without a galactic commission having to send an expedition to inform you of that, That's lifting you can do on your own. But what I want to point out here, this is the last 22,000 years, and see how from basically up here at the top of this little hill, that's where Homer sang his song. And from there on, at this scale, it looks just like a completely uninterrupted, perfectly smooth descent into hyper-novelty. Now, when we get in there and see the details, you will see that curve is not smooth at all. It's tremendously interrupted and punctuated, yeah.
Where would the King Wen thing be on display? Is there a King Wen?
No, well, we're in the wave. The wave is being formed by, it's an imprecise term, but interference between King Wen's sequences.
But what time was the King Wen's
Oh.
sequence formed on this? You see what I'm saying?
1185 BC.
Yes, where on the wave would that be?
That's roughly right up here where Homer sang his song.
Okay.
Same, close enough. Huh?
Mount Helicon?
Yeah. Yeah. Okay, now, it's all very well when you're talking about glaciations, extinctions, continental drift, things where you have not great precision. But if you're of the kind of rationalist I am, you should be able to anticipate that this is going to be a tougher row to hoe as we get closer to the present, for the obvious reason that we know more about the present, and we know it with great precision. October the 12th, 1492, July 4th, 1776, August the 8th, 1914. It begins to get constrained. And so if your theory is right, the stakes rise. So having paused here 22,000 years out from today, let me resume the zoom. And I guess we'll still do an approach factor of 2.
Aaron, how did you establish 0?
Matching your way.
You mean
In the habit novelty.
well, I wanted infinite novelty to have a special value. So 0 is the only special value there is in the integers. So, and also people sometimes say it's counterintuitive. Shouldn't it be that novelty increases when it goes up and habit increases when it goes down? And the answer is no, because first of all, that would mean that high novelty would just be some arbitrarily high number, where if you can watch it slowly over centuries and millennia make its way towards 0, there's a certain drama in that I like. And also, because this was coming to me out of the psychedelic place, wherever that is, I had the image of time like a river. And I wanted infinite novelty to be the ocean. So time had to flow downhill to get to the ocean. So I think of it begins in the arid highlands of habit and then flows thousands of years across ever descending terrain until it finally is merged with the infinite ocean of novelty at altitude 0.
I have a related question. How did you know to put it to a calendar, to a date, to time?
Again, it was largely intuitional. I saw that there are... The I Ching is composed, as you know, of 64 hexagrams. Each hexagram is composed of 6 lines. 6 times 64 is 384. Now, 384... as a calendar number, at first doesn't look too inviting. It's 19 days longer than the solar year. So if you actually had a calendar of 384 days, it would precess 19 days against the solar year. Nevertheless, it turns out in ancient Israel, there was a 384-day calendar, and parts of Islam still use a 384-day calendar. I'm not sure. I think it's a calendar pre-Deuteronomy. But the number 384 begins to become more interesting when you realize that a lunation is 29 and change days. 13 lunations is 383.89 days. It's within rat's eyebrow of 384. So then I thought, well, this is a lunar calendar. A 384-day lunar calendar. And I conferred with Wolfram Eberhard, who was my teacher in all things Chinese, and he had studied the Chinese calendar. He had no idea what my insane agenda was. He just thought I was a really motivated undergraduate. But he blessed all these conclusions and said, this is all within the Ven of ancient Chinese thought. It's all creditable. Yeah.
It also seems, if I may say so, that your counterintuitive notion of the direction of novelty as opposed to habit is partaking of some sort of, there's something else going on. Some sort of muse was working with you, because not only did it sort of resonate with your own journey, you went to India, and the kind of journey there was always up to the peaks. And then you went down, descended to the Amazon, and just in this sort of symbolic universe, there seems to be a revolution going on in a spiritual paradigm where people are saying enough with this transcendent stuff.
It's in the humid lowlands. Is that what you're saying? Yeah. I can appreciate that.
The Renaissance wasn't. You mentioned the Renaissance. There's another resonance that the Renaissance didn't start by getting real spiritual. It was when what's his name? Was it Petrarch?
Petrarch
started the Renaissance by coming down. He took Augustine with him, and had this. Was thinking of having this vision, and instead he left his transcendence and that his soul was too attached to literature and poetry and love for his Laura, and went down into the Renaissance.
Yes, so, I'm familiar with this incident.
Yeah. So there's something else going on that you were kind of plugging into that's part of a whole symbolic revolution, I think, that's going on now.
Well, it couldn't have been otherwise, I think. Let me run this thing forward now. Okay, an approach factor of 2. So it's 22,000 years. There's the last 715 years. See the Italian Renaissance, that long, low period, that's the era of exploration. There we are from the European Enlightenment to the present. There we are from the early 18th century to the present. That's the 20th century, most of it. That's from roughly 1948 to the present. That's roughly from sometime into the 70s. This is the last 11 years. The last 5 years. The pointer is pointing at today, by the way. The last 2 years, and that's enough of that. And as you can see, if we were to reconfigure the thing, we could see into the future.
What's the drop there?
The one that we just came through is, well, let's see. The Martian meteorite, the cloning of Dolly, all those things that happened last year in 1996. 1996 was a test case for the theory, because I've been saying since 1975 or something that 1996 would produce a definitive novel event somewhere within 2 weeks of the 1st of August of that year. And the Martian meteorite is good enough for me. That's the confirmation of extraterrestrial life. And some people say, well, that's nonsense, and it was bogus, and blah, 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 blah. But nothing that enormous arrives uncontested on the human plate. So I think I'm still in the running. There's a short developing. Okay. Okay, so now normally how these lectures proceed is we go slightly more slowly through this, and so then we've arrived at the end of the lecture. However,
the point on there, from here, it looks like it's reached the...
Oh, it looks like it's touching zero. No, it isn't touching zero. The nature of the software is to always allow one point to touch the horizontal axis. But there's only one point in the entire system that has a valuation of zero. So now the new part of the thing, or what I want to talk about coming out here, is 2 years ago there is a curious property to this thing which I don't yet understand, and I'll briefly sketch it out. It's that when you look at billions of years, the computer has something going on in the software where it keeps track of days to end. It's not a piece of data which is ever displayed on the screen, but it's a piece of data which the program needs to know. It needs to know the days to end. And we discovered about 4 years ago that if you put 6 billion or 20 billion years on the screen, and then you go up to one of those peaks, and to the exact day of the peak, of the shift, where it goes over the point, and if you then look into the guts of the program at the days to end number, it is in an extraordinary number of cases either a prime or the product of two primes. This either astonishes you or means absolutely nothing. But it's quite peculiar. Well, and quite unexpected. And so then there was some hope that there was a way to reconfigure the thing to actually search for large primes, and that there was a way to sort of reconfigure it and search for large primes. This was about 3 years ago. So I got into email correspondence with a mathematician in England about these primes. And then we agreed that we would meet in Palenque 2 years ago. And he came to see me. And it was his name is Matthew Watkins. And if you go to my website, you will see that there is a button there called the Watkins Objection. We met to discuss this search for primes, but as our mathematical discussions unfolded, it began to become clear that we had a problem. And the problem was that Watkins felt that he had discovered an error in the mathematical formulation of the wave, and it centered around a very arcane detail in the construction of the wave, which I won't even begin to make clear to you what it was. But he and I understood each other, and I understood that if he was right, as he thought he was, that I was in deep shit indeed, because if he was right, I had made a mistake. And the thing that the Logos had wanted me to do with the King Wen sequence, I had made a blunder. I knew what the Logos wanted, but I had made an error, was Watkins' position. And it was a difficult experience for me, not only because I didn't know how I was going to feed myself if this thing went up in smoke, but it was very hard for me to understand Watkins. And any of you who are professional mathematicians who try to talk to me about this will discover that I'm an idiot savant. You know, it's mine, I invented it, but I can't defend it in academic mathematical terms. I don't think of myself as Einstein, certainly, but there is a story about Einstein that after he published the general theory of relativity, a physicist named Hermann Bondi launched a furious attack on it. And Niels Bohr went to Einstein and he said, Bondi is saying all these things, he's publishing all these papers, what are you going to do about it? And Einstein said, I can't do anything about it. I cannot understand the man's objection. So, so this was the position I found myself in. Watkins was terrifying. I never had the guts to ask him how old he was. My guess would be 19, something like that. I mean, just one of these flaming geniuses, just one of these people for whom quadratic equations came like walking, you know. And so we had this series of, I thought of it as the meetings by the pool. We had 3 long meetings by the pool where my world wilted, curled, melted, retracted, and finally it was very sort of sad, actually. And but it wasn't definitive, because I could not understand him. And he was also, I think even he would agree, arrogant in that way that you're trained to be in the British university system. I mean, you are to be scathing. You are to take no prisoners. And he said, I want to write a paper about your wave. And I said, fine, and we'll put it on the website. And he said, what I'm going to put forward my objection. He said, what shall I call the paper? And I said, well, how about Autopsy for a Mathematical Hallucination? When you really get into the spirit of this thing, you say, let me guide the knife. Let me turn on the saw. Don't trouble yourself. So how about Autopsy for a Mathematical Hallucination? And he said, fine. And then he did it. And it was, several pages of mathematical notation and several nasty paragraphs. And I sat with it for months. And then I said, I can't really understand Watkins, but I do understand what I intended. And so what I'm going to do is I'm just going to answer his objection by, once again, as clearly as possible, defining my methods and putting that on the internet, and then let the chips fall where they may, and some third party will have to resolve all this. So I did that, and Watkins took a leave of absence, and I understand he was last seen somewhere in the west of Ireland with a donkey and a harp. Truly. And he basically then just dismissed the whole thing and said, well, you're a cult, your people are morons, you can't even understand this objection, and this whole thing is really boring to me. And so then it was sort of left like that. But I got good support from my mathematical friends, and Ralph Abraham was wonderful, and he said, he told all kinds of stories from the history of mathematics about people who had made enormous blunders whose names are still enshrined in the stars, and on and on. But I really felt shaky about the whole thing, and I talked about it at Esalen. But Watkins never dealt with the fact that the wave did describe time. He wasn't interested in that. He just said, you made a mistake, and so why should we talk any further? You made a mistake. And so trying to say, that it adds up or it looks good or so far, you made a mistake. Well, in the past 7-8 months, I've been working very quietly with a person who came out of the woodwork, and I don't think he wants his name yet spoken in public. So all I can tell you is he is a professional mathematician. His ordinary job is modeling thermonuclear fusion processes for the United States government at a desert installation somewhere in the American Southwest. His mathematical credentials are impeccable, and he said, I want to go to bedrock with this Watkins thing, and I'm going to do a complete vector analysis of the wave and break it down at every level, formalize every step, and try to understand what has happened here. Because he, like me, liked the theory. So we've been working very quietly, or rather, I've been reading his email, and he has been working. And here's what we come up with. I made a mistake. I did make a mistake. That's, for me, the bad news. But it turns out that the mistake I made was tiny. The wave that you saw tonight, the wave that I've shown you over and over again, year after year, is, and this is not a fuzzy figure or a guess or anything like that, it's wrong by 3%. There's a 3% difference between this wave and the wave that all parties have now converged upon as, in fact, the true wave. We call this the time wave, TW. We're calling the new one the CTW, the corrected time wave. My mistake was as Watkins defined it, but he never carried through. Something about his way of thinking was, once he discovered I'd made a mistake, for him, he felt that, if we think of it as a game, that he had won the game. He never went on to see what the consequences of the mistake were. And the consequences of the mistake were to distort the values by overall 3%. Hundreds of screens are within less than 1% difference of each other. The overall conclusions that come out of these 2 years of mathematical hell that we've embroiled in is actually we're now in more robust shape than ever, because thanks to this gentleman's work, which will be posted on the internet shortly, and all of you who have Timewave Zero software, we're going to put a file up which you will be able to download and pull out the bad values, plug in the good values, and then the interface will run the new wave for you. And good news from my point of view is that in the process of this going on, the time wave has gone from being the mathematical hallucination of Terence McKenna to a vetted formalism, having been hammered on and had its tires kicked by some of the best mathematicians in the business. All stages in the construction of the wave are now formally defined. The overall effect of adopting the corrected time wave is truly good news, and it should be surprise to no one. It turns out the universe is even more novel than I thought it was, because the new time wave tends to start closer to zero and hew closer to it as it moves along. So the overall picture that emerges is of a more novel universe than we thought we had before. And then, and this is, to my mind, the ultimate payback, though I have always argued publicly, feeling it was the obligation of the public to be my opposition, though I have always argued publicly for the congruency of these screens to historical data, I've always been aware of a couple of things that were puzzling to me. One of them was, why is it that plunge into novelty in the 10th century for the Umayyad caliphates reaches a greater depth of novelty than the founding moment of Islam 200 years before, when it seems derivative of Islam? And I just held this in my mind. I felt, I need to study the Umayyad caliphates. I need to study the foundation of Islam. I need to figure out why this is. But it always irked me. Nobody ever mentioned it to me or pointed it out. I discovered this slight discrepancy in my own intuition about how the wave should work. I also discovered another slight discrepancy about my intuition how the wave should work, which is, I always felt that the novelty graph for World War II should reach the greatest descent into novelty at the use of the atomic bombs over Japan. After all, a new physical principle is involved. But I always knew that by the old time wave, the winter of 43 was weighted as slightly more novel than the August of 45. And this troubled me. I'm happy to report that with the corrections in place, both of these problems have been rectified, and now the founding moment of Islam is more novel, slightly, than the Umayyad caliphates, and the use of atomic weapons over Japan is more novel, slightly, than the Battle of Stalingrad. And there are a couple of other areas, too technical or too obscurantus to go into at the moment, but to me, it was a win-win situation. The only slightly galling thing about the whole thing was I personally have to admit that I made and defended for 22 years or however long it was a 3% skew of the values because I made a methodological error in the scoring of the time wave. Now that that's corrected and that we have a complete vector analysis of the entire wave, and it is now a completely explicit mathematical object that any trained mathematician in the world can now answer any conceivable question that might be put about its formalism, we're ready for prime time, I think. Yeah. Yes, 3%. No, that's all. It has nothing to do with that. All that stuff about 2012 and all that you get to keep, that was never even up for grabs. But I'm sorry I don't have an overhead projector. Maybe we could bring actually the lights up a little for this. Gently, please, for the cannabinated among us. Yeah, I want to go back to that. To explain to you what I mean, I have a couple of illustrations here. Yeah, I think so. Remember, I've talked for years about history's fractal mountain. Okay, here's what I defended for 22 years, this wave. Here's the truth of the matter. CTW. Yeah, that's the CTW. over here.
When's the next mountain? When's the next mountain?
September 7th, we have been moving upward into habit, and on September 7th it will turn down. We are now undergoing a series of oscillations before 2012. I'll leave this up after this evening, or for the rest of this evening, and if you care to stay after the lecture, you can play with it. There's always people in the room who know how to rescale it and run it for you. I don't know how well you can see these, but do you see that it's damn near at this scale the same way? But in fact, it is not the same way. Okay, so that's history's fractal mountain. This is what I thought it was. This is what the new vetted, corrected, and cleaned up version turns it out to be. Here are some more examples. This is from, now this one is more dramatically different. This is from 213 BC to 6, I don't know what's going on. Oh, to 2012. Now wait a minute here. I'm not sure enough of what this one is to show you. Here's two versions of 1905. Old wave, new wave.
Oh, it is different.
Yeah. In certain situations, it is different.
So the dates actually must change then?
No. Well, not the end date.
Not the end date, but like, for example, when you just said September 7th.
Oh, things like that change very, very slightly. Or actually, sometimes what happens is that the actual transition date doesn't change, but the path of the graph to it and from it has a different topology. I think you see that here. See how these both reach their novelty maxima at the same point, but the path to it is different.
So did the correction that was made, did it address all that issue that we found about the planets?
No, that was completely left in the dust while all this other fighting went on. Here's the one that shows one of the places where I myself had doubts. This is the period from 1935 to 1955. In other words, including all of World War II. Here's the old version, new version, and the 45 is weighted heavier here, and 43 is weighted heavier here. So it's amazing to me that I could have claimed for 22 years that it described time, argued all these cases, finally gotten it straightened out, and discovered that it describes time even better than it did before.
Have you found any new discrepancies or anything? Have you had a chance to really go through the whole thing really with a fine-tooth comb?
No, see, I haven't yet actually had a chance to load the new data into my own version of Time Wave Zero. When I do, I'll go through really with a fine-tooth comb, as you say, because there are about 50 or 60 historical incidents that are indices for this. They all have to be looked at. Now, here are two that are quite different. This is 1915. Old version, new version. Now, the World War II began in 1914.
World War I.
Sorry, World War I. I said it began in one? Couldn't be. No, yes, World War I began in 1914. So again, you see that the new data is much more congruent with the facts of the matter. And so forth. Let's see if I have any others that might be at a glance useful. Well, here's one. This is the one we've always argued over all these many years, and it's interesting. This is the one basically from the fall of Rome to the present. Old version, remember, and here's foundation of Islam, Umayyad Caliphate. You've practically memorized this stuff. Black Death. I know there's the Black Death, and there's the Renaissance, and there's the Enlightenment. Here's the new version. Quite interestingly different. Much food for thought. So, bottom line is, as I said, all I had to do to make this a field of genuine human study and endeavor instead of my own little bailiwick is admit that I made a mistake, which I freely do. I did make a mistake, and I should say I'm grateful to all of the people who participated in this. I don't mind. I've never feared the knife. And,
including the young mathematician.
Yes, Watkins first and foremost, because he put his finger on the error, and then it all proceeded from there. And the whole thing has been, since its conception in 1971, moving slowly toward a process of being an ever more robust object in the theater of intellectual discourse. And I didn't bother to bring my colleagues' notes over tonight because it would be like exhibiting hieroglyphs to collies. At least it is to me. But he has produced, 8 pages of vector analysis that just lays the whole thing out from A to dot. Yes.
Terence, can you explain briefly again what you mean by the end of times?
Well, simply this asymptotic explosion of novelty. In other words, what is it like when you have more change in a single day than you used to have in 1,000 years? What is it like when you have more change in a second than you've had in the previous 100,000 years? I'll lay out for you the mathematics of the time wave in terms of its closure, and then we can probably call it quits. But here's how this theory works. Here's the kind of universe this theory says we're living in. It says that the universe is approximately 72 billion years old. That's a lot older than orthodox astrophysics says. They're fighting over whether it's 9 to 14. This theory says it's 72 billion years old. That's the first cycle of its unfolding. 1/64th of the way from the end of that cycle, it enters another cycle. That cycle is 1.3 billion years long. It's another level of concrescence, and I take it to be the domain of life. That's about the amount of time life has been around. Well, the next level is 275 million years long. What we're doing each time is we're dividing by 64, nothing complicated. So 72 billion divided by 64 equals 1.3 billion. Divided by 64 equals, I'm guessing, but roughly 275 million. Divided by 64 is, I don't know, 3 or 4 million. Divided by 64 is 175,000 or something like that. Divided by 64 is 4,306, the domain of history as we know it. The next division is 67 years, the period from the moment of the dropping of the atom bomb on Hiroshima until the solstice of 2012, 67 years. The next cycle is 384 days. It will begin late in 2011. The next cycle is 6 days long. Now understand that in each one of these cycles, as much novelty happens as happened in all the previous cycles. So from 384 days, you go to a cycle 6 days. From that, you go to a cycle 1 hour and 35 minutes long. Then you go to a cycle 1.5 minutes long. Then a cycle 1.3 seconds long. And you just keep doing this, dividing by 64, until you reach the domain of Planck's constant, 6.55 times 10 to the minus 25 erg seconds, technically known as a jiffy among us professionals. And beyond the realm of the jiffy, there is no need to carry out these divisions because because it means nothing. You've reached the grain upon which reality is being printed. There is nothing. Well, so if we have a universe that is undergoing this collapse into hyper-novelty, and it has to start at age 72 billion years and collapse down to 6.55 times 10 to the minus 23rd erg seconds, how much time do you think it has left in its existence when it's halfway through the process? And the answer is 1 hour and 35 minutes. In other words, what we're saying in this cosmology is that the universe will undergo half of its evolutionary unfolding in the last 1 hour and 35 minutes of its existence. And that's what I mean by the end of the world. I mean that, there will be more novelty jammed into every nanosecond of those last 35 minutes than there previously were in millions of years of cosmic time. It's as though we're falling into a black hole, not of gravitational compression, but of novelty. And it's what has called us forth out of animal organization. It's what has put these enormous technical tools in our hands. It's what shapes our dreams. It's what's calling us home. It's why I believe that in less than 100 years, this planet will be, from the human point of view, empty. I mean, the thing, whatever it is, will have come and gone, the novelty. And I suspect what it is it's actually some kind of other dimension. It's the way I think of it is novelty is crowding into three-dimensional space-time and crowding in. What happens in 2012, December 2012, is the three-dimensional space-time continuum will be unable to contain any more novelty, and like water flowing out of an overfilled bucket, the novelty will actually begin to push into another dimension. It will actually force into existence another ontological dimension to reality that will contain it. And we call this true pure spirit, or the coming of Maitreya, or the end of the world, or human languages are utterly inadequate to this. And we're not causing it. We can't understand it. We are like corks on the cosmic ocean being carried toward what is essentially the climax of physics in three-dimensional space-time. And people who say, well, don't you find it rather odd that we're here to witness it, means you didn't understand the theory. We're here to witness it because we were called into existence as part of the process. We're here to witness it because if it's happening, we're happening, because we're part of this expression of novelty. We're part of this alien thing. It's always been revealing itself, but at ever greater speeds And, somewhere around 50,000 years ago, if you were paying attention, you would have smelled it in the air. And if you weren't paying attention then, check back at dynastic Egypt. And if you're still too dull to pick it up, check in on the 20th century. And I don't think anybody can miss it now. The air is filled with the eminence of the eschaton. I mean, we are now so dynamically locked with this field of attraction that all you have to do is take a cat nap, smoke a J, lie in a hot tub, and it's waiting just behind your eyelids, just under the surface of ordinary reality. You don't have to look far or move fast to find it waiting. The sense of the eminence of the eschaton is the pervading essence of life in the 20th century. Or I'm a monkey's uncle. Thank you very much.
You're listening to the Psychedelic Salon, where people are changing their lives one thought at a time.
And that was how Terence expected the world would come to an end on December 21st, 2012. Or he would be a monkey's uncle, so he said. But let's see if there may still be some redeeming value from Terence's big ideas about time. Although there was a lot of dead air in this talk, as Terence and his friends were looking at, whatever was on his computer screen at the time, you now have a complete audio recording of one of his Saturday night sessions where he gave his standard time wave talk. And if you'd like to listen to the first part of the next time that he gave this talk, late in the same year of 1997, well, you can listen to that in my podcast number 204, which I posted on November 18th, 2009. I think that I maybe only played the first 20 minutes or so of that Saturday night talk in the podcast, but you may find it interesting anyway. Now, when Terence said that the universe has an appetite for complexity, as the universe grows, it grows ever more complex, well, that does seem obviously true. But we don't have to actually look at the entire universe to come to that conclusion. Just look at your own life. From the time you were an infant until now, well, it seems to me a safe bet that your own life has grown more complex as time has progressed. Now, I don't have any suggestions as to what that may mean, but it is something that I'm going to give a little more thought to. Most people that I know from time to time say that they would like their lives to become simpler, less complex. So, is that actually possible without reversing time? Another thing that Terence said in this talk was that there would be more change in the next 10 years than in the previous 5 million years. Well, it seems to me that while inventions like the airplane, the automobile, and the telephone, not to mention computers and the internet, certainly seem to support his hypothesis, what is left unmentioned is how we define change. Are we talking only about technology? Or should we also be looking at things like human behavior? When you consider the barbaric ways in which we humans seem to be treating one another, well, I'm not so sure that much change has taken place at all since 1997. And then there's this point where Terence said that he believes that the universe does know where it's going, because it's going even deeper into novelty. Well, I can buy the even deeper into novelty idea, but I've got a real problem with thinking that the universe itself knows where it's going. Doesn't that give some kind of essential life awareness to the universe itself? Is he saying that the universe is some kind of a being that can actually know something? I don't think that Terence actually meant that, but his language there is a little bit loose for me. So those are a few of the ideas that this talk of Terence's sparked in my mind as I was listening to him just now, but there is something else that came into focus for me as well. And don't get me wrong, I'm not about to throw the baby out with the bathwater, so to speak. The overall majority of Terence's ideas I have always found quite scintillating. And even though I disagreed with him about the time wave, well, that doesn't mean that I haven't been thinking about some of the implications of that idea. But I think we have to face up to what I consider to be a few serious flaws in his time wave hypothesis. Besides the fact that there was no great shift that we know of that took place in 2012, as he said in this talk, and I quote, "Where the endpoint is determines where all the other data points fall, and this should be self-evident," end quote. Of course, this then opens up the possibility of moving the endpoint and having at it once again. But are you sure that this would really be a good use of our time? As Terence has made very clear, the graphical chart of the time wave is, at its most basic level, a graphical representation of the I Ching. It is a graph created by manipulating the multiple ways the I Ching may be interpreted. I could go on, but you're every bit as smart as I am, so just think about that for a while. As he said, that's where I got the curve. And it doesn't even purport to be a representation of the meaning of the I Ching, but only of the differences in the symbols. And that is the basis of his wave, which, as it turns out, is also a fractal wave. So, besides accepting the I Ching as the ultimate divination tool, the time wave also requires that we reject the possibility that human history is cyclic and instead accept it as a fact that history is fractal. And, of course, there is also the fact that to support this hypothesis, Terence very blandly ignores the entire field of astrophysics and declares that, contrary to virtually every scientific opinion, that his opinion is that the universe is actually 72 billion years old. And that's just one stretch too many for me. But then again, it's something you're going to have to decide on your own, because I'm certainly no expert on these things. Now, those are a few of my major complaints about Terence's time wave hypothesis. And let's be honest here and not call it a theory, unless, of course, you can say it actually has been tested and it failed. However, maybe we should hold on for a moment here and take a little closer to listen to some of the things that Terence had to say about time itself, and see if there still isn't some of his work here that is worth looking into a little more closely. What I'm thinking about is the nature of time itself. Just 2 days ago, my 11-year-old granddaughter asked me why sometimes time is fast and sometimes time is slow. And since I was just previewing today's talk at the time, well, the way she phrased it struck me. She didn't say, "Why did time seem to go fast?" She said, "Why is time sometimes fast, and why is time sometimes slow?" Is it? Is time fast and slow? We've all had experiences of time seeming to move at different speeds, so what's that all about? Well, if you are a physicist, you can now breathe a sigh of relief here, because I'm not going to suggest that we screw with the way that we measure time in the physical world. For one thing, if time wasn't linear, our computers wouldn't be working right now. But emotionally, time does seem to have different properties under varying conditions. So what I've been playing with these past few days, when it was too hot in this little room to turn on my computer, is that I've been experimenting with ways that an emotional time wave could be created for our own lives. And one of the things that always bothered me about Terence's wave is that his proposal that novelty never goes away, never goes below the horizontal axis. And I don't know, that just didn't feel right to me. So in my little experiments, all of which pretty much suck, by the way, but anyway, I used a plus and minus scale indicating whether I was feeling good or feeling neutral or bad at the time. And I've experimented with several ways to set plot points, like the day I began a new job, personal anniversaries, age, health, things like that. But to tell the truth, with all those various graphs, I still haven't come up with anything very revealing. Maybe if there was a standard way to do this and we all overlaid thousands of charts, then maybe something could be understood about public moods or how movements begin. What I'm really trying to say here in this long-winded rap is that even though Terence's time wave hypothesis has been shown to be wrong, maybe you or one of your friends will find a little meme in there that will eventually grow into a better idea of how best to think about time. But you know, we still have to give the devil his due, so to speak. Near the end of his talk that we just listened to, Terence, speaking in early August 1997, stated that the next big descent into novelty would take place on September 7th of that year. Do you remember what he said?
When's the next mountain? When's the next mountain?
September 7th, we have been moving upward into habit, and on September 7th it will turn down.
And while the 7th turned out to be a relatively quiet day, the day before certainly wasn't, because it was on September 6th, 1997, that 2.5 billion people all around the world watched the televised funeral of Diana, Princess of Wales.
You're traveling through another dimension. A dimension not only of sight and sound, but of mind. A journey into a wondrous land whose boundaries are that of imagination. Your next stop, the Twilight Zone.
And for now, this is Lorenzo signing off from Cyberdelic Space. Be well, my friends.